Hello, folks. So I'm actually solving this LeetCode problem 1007 1007 minimum domino rotations for equal row problem, and this is part two. And I'm actually gonna write down some more test cases so that I don't mess up the way I think. Because till now, what I was thinking was. If there are, let's say, if the thing is like this, for example, this one, right? Um, so this and this, right? The plan was I'll go through the top and be like, how many twos? One. How many ones? One. Later, two is two. Later, four is one. Two is three. Two is four. This is for the tops. For the bottoms, I'll be like 5, 1, 2, 1, 6, 1. Like go through it and tell how many occurrences, right? 2, again 2. This time I'll be like, okay, 2 plus 2, 4 occurrences on the top, 2 occurrences on the bottom. Total itself is 6, 4 plus 2, 6, we are done. But then the problem is, what if this was the 4 and this is the 2? This 2 actually cannot be swapped. I'm still here. I still haven't gone to 3 or 2. This 2 cannot be actually swapped, right? What if there's no 2 here? For example, let's say this is 5, right? This 2 is not the same as this. Like, this is the same as this, and we cannot swap this and say, oh, now we can do 2, 4, so do 2 rotations and we're good to go. No. You do 2 rotations, this is 1, and then you do 2 more, it still doesn't make 6, right? So you need to understand the locations of these twos. If the top one is also a two, you cannot actually count it, I think. Um, yeah, I mean, it doesn't make sense to count it, or yeah, I mean, and it doesn't make sense to rotate it also, right? If the top and the bottom of a thing are same, then I think it just doesn't make sense to count it. So I think instead of going through the top first and then the bottom next, I think we should just go with top and bottom and go through these one by one. And if both are same, don't even count the occurrence of it. Right? But does it even make sense? In the tops, you can have the occurrence. In the bottom, we don't have to have the occurrence because we don't want to consider it as a thing. And hmm, it's a tricky question. Like for this, no number of rotations will actually help you get twos all the way, right? Instead, if it was actually something like this, yes, you would get it, but you still have to go till this three and then the next two. Three is one, and then you have three twos in the bottom, four twos in the top. Add up, it doesn't make sense. It doesn't make six. That's because there are some twos, duplicate twos and whatnot, as in more like both are twos. So you should consider this as one, two actually. So, hmm, maybe we can do something like this. If both are twos, then we consider that we are looking for, if we are looking for twos, it should be one less because these two are twos. Top and the bottom, we just have to separately check occurrence. All right. What other way can we do this? Apart from checking the number of occurrences, um, go through both of them in one go, in one pass. Don't have to go one this and then another this, that many numbers, but instead go through together In which case, if both are equal, we just take it in the top or in the bottom, only one of them, right? And only once, and move on. So, 2, 1, 2. This one, if it's taken on the top, then it's 3, 4. This won't be taken. 5, 6, right? It's taken in the bottom, it's 1, 2, 3, 1, 2, 3, 6. So let's try that out. And I will actually take up this example of zero rotations or like -1. Nothing can be done to. Actually, minimum is 1, I think. Minimum length is 1 for the tops. I'm not going to take length 1. Minimum length is 2, so I'm not going to take length 1. So leave it, right? So let's not take that test case. And for this, one moment. 2, 2, 5, 1, 2, 1, 2, 5. Did I just copy paste this? 2, 1, 2, 1, 2. Okay, yes, I did copy paste this. In one of this, I'm just going to say um, this will be start once, this will be start once, and we're done. Instead, we'll actually make this as and we make one of them as a 5 over here. So you can't start, there's no 2 here. So interestingly, the number that's coming up should be there. For example, go through both of these. The number that's coming up should be there in all of them. Let's say it's gonna be 2, then it should be 2 should be here. Or if it's gonna be 5, then 5 should be here. So one of them should be here. If not even one of them is here, let's say these are all different numbers, then you can just say -1, right? Quickly. Because you can't swap any of this to make it as same number. So in the first go itself, you can just say if there are 4 different numbers, you can just say it's -1. For example, um, I haven't created a case like that. I haven't created a case like that. So if it's 2, 1, and then 3, 4, it's actually -1. All the numbers are different, right? So anytime you see that all the numbers are different, you can just start getting rid of things, right? Isn't just be like, okay, we have 4 different numbers, none of it can be swapped to make it look the same, so you can already stop and say it's -1. So here you can be like, okay, 2, 1. Next one is 5, 2. To match, we can rotate this once. At least this can be matched, right? So we can rotate this once, or you can rotate this once. This can be matched though, but so we're just moving on. And we keep the count of the twos, right? Next, if it's 2, 2, then we leave it. But 1, 2, again, it can be matched, like the 2 can be matched. Hmm. This is supposed to be a medium problem. I think this seems a bit easier. Hmm. So I think I also copy pasted these. Yeah, copy pasted these. What was it? I think we did Yes, and give here 2 and 5, and this will be minus 1 because this 2 just doesn't make sense. It says 2 2 and it says 5 1, so this can't really match it. If there's not even one matching, then just leave it at that. So the row of dominoes represent the top and bottom. Uh, Here the dominoes so that it is a minimum so that all the values in the tops are the same, or all the values in the bottoms are the same. So I was planning on just keeping track of the occurrences, but then you can actually find out if it's not going to work out very quickly without keeping track of occurrences, right? Like looking at four values like this and be like, there is nothing that matches these two rows, like these two adjacent columns. How are you going to swap any of these to get it to match, right? So either these two match, or these two match, or these two match, and or these two match, right? So we can keep it as A and B and C and D. Either A and C match, or B and D match, or A and D, or B and C, right? So then none of these match, then it just doesn't make sense, right? You can just quickly say that there won't be anything. And let's say they do match, something does match. For example, AD matches, BC matches, or AC matches, BD matches. The next thing can be matching, and then you keep track of occurrences, I think. And you also ensure that C and D are not the same, or else you keep don't track only in one of them, either in the top or in the bottom. So that you can just say, um, actually, that is also true. If let's say you have this going on, you rotate this, you're going to go. Here, you need just two rotations, right? How do you say you just need two rotations? You calculate two, one, two. If you take this two, if you count it on the top, then this is four, and this is two. But if you count it at the bottom, this is three, this is three. You just say three rotations, but actually you just need two rotations, right? So the one occurrence of two will go to the this occurrence of two should not be considered. And if you're looking at occurrence of two, um, there should be three and two, except five. And finally, you should be like this is a double, and say this there is a double, and say there is one two, a double, right? Now, since if there is a double, you count that double also as one, right? So three, two, and then one. How many doubles? Is it one double, two doubles, three doubles, right? So we say tops and bottoms, right? So we basically we go through this and we say, okay, this value, is it there in bottoms? Is it there in tops and bottoms? Add up all the values and you get the thing, right? And we look at this, right? And then we say finally, if we find that all the values are different, A is not equal to if all the values are not equal, like if none of the values are equal, like AD is not equal, AC is not equal, BC is not equal, BD is not equal, like all the values are different, then which is A is not equal to C, A is not equal to D, A is not equal to B, right? So let's run AC, AB, and AB. Where is AB? Oh, I missed AB. So, I mean, AB doesn't have to be the same. We just need this to match with one of this, or this to match with one of this. So A is AC, AD, BC, BD. BD, BC, BD, yeah. So these two, it doesn't make sense to match, AB and CD, right? Um, it says this, this and this. If these two match, great. These two match, great. There is a possibility of things to go forward, right? But yeah, of course, after this, let's say you have these two match, and then there's nothing that matches the next one. I don't know. Like in the first go, if you notice this, these are not equal, then it's gone. But let's say you have something like 1 and you have 4, okay? And let's say you have 5 and let's say you have 6, right? It can even be different. It can also be 1, 1, and then 5, 5, right? Now here, all these are not matching, but let's say they do match. For example, let's say you have 2, 4, and then 5, 2, right? Or you have 2, 4, and 4, 2, 4, 2. In this case, after this, if it comes up as 1 or 5, 1, 5, then it's a problem, right? If any of these match, but then this doesn't, I mean, either this two or this two match, it does match. This two doesn't, this two doesn't, it's okay. This two matches, great. And if this two also matches, great. But if this doesn't match with anything here, then you basically know that you can't make any of them same because they want minimum number of so that all values in the tops are same, or all the values in the bottom are the same, right? So if you see something crazy like this, or in this case, for example, this two are the same, but then you find out not a two, but you instead find out a one, and then you find out a six. That's all. This is nowhere close to minimum, right? So yeah, so you have either twos and hmm, can you draw like a graph over here? As in, when you see that twos are matching, then you go like this. For example, in this case, twos are matching, so you go like this, you go like this. You can go like this, or you can go like this also, right? Go this, right? And hmm. So over here, you can easily say that this will never turn out, regardless of how much other stuff is there after this, right? Because of this 1 and 5, you can't just make a cut at all. You can't have fours or you can't have twos. Just have to go with. Maybe we can do this. We can count two as ones and 4 as ones. In the next one, it should be clear that there is an existing 4 or an existing 2. Like one of these must be there, 4 or 2. Both of these are not there, then it's gone. So till now, whatever you've seen, it must be there. So hmm, either from the tops or either from the bottoms, it must be there. So you have 1, 2, and 1, 4, and 1, 2, and 1, 4 in the bottom and in the top. You go for 1, and you're like, there's no other 1 here. And there are some values already existing. And in the top or in the bottom, there are no ones that you just noticed. No ones that you have noticed till now. So will it work? No. And no fives. You're like, okay, it won't work. But mm, this also won't work because it doesn't match with this or this. This is not with this or this. It matches with this, I can just swap this. Matches with this, I don't have to swap it. I just keep going. I just have to see if this is the top value, previous value, bottom previous value. Whenever I look for the next top, I have to see if the top previous value or the bottom previous value is the same as this, or bottom previous or the bottom is equal to the top previous value or the bottom previous value. This with these two, so this with these two, this with these two. If none of these match, this matches with none of these, this matches with none of these, then we can just say there won't be any, right? Think that's what is happening here, right? So anytime we find this, we can actually go ahead and tell that this is not going to work out. For example, this one, you can say -1, and you can say 3 and 4, right? So, keep these up. I'm going to go ahead and think more about what else to do about this and how else to solve this. But yeah, these are some of the test cases that I can think of. I'll create another part for this and I'll try to solve it. That's all I have for this video. Until next time. Bye.